In this video, we'll discuss several examples of second-order linear differential equation whose coefficients are unknown and also homogeneous, right? Let's try to apply the procedure we have learned to solve them, right? Three of them are uh, just a differential equation, and the fourth one is a initial value problem. So let's see the first one. We have 2y double prime minus 5y prime minus 3y equal to 0, right? So we just try our uh, method on this differential equation, right? So let's try to go through the whole procedure here one more time. So based on our discussion, we know that the solution of such an equation should be exponential function, right? We assume y equal to e to mx, which means y prime is m e to mx, and y double prime is m squared e to mx, right? We plug that into our equation, you get 2m squared e to mx minus 5m e to mx minus 3 e to mx equal to 0, right? Common factor is e to mx, 2m squared minus 5m minus 3 equal to 0. And because the first factor never equal to 0, so this equation equal to 0 if and only if 2m squared minus 5m minus 3 equal to 0. So this is called the auxiliary equation. By solving this, will give you the solution, the general solution of the initial original differential equation, right? How do we solve that? We can factor it, or you can use a quadratic formula, right? Which is, let's try to use that. M1 is neg negative negative b, right? Negative b. So this is our BAC, right? Minus square root b squared 25 minus 4AC minus 4AC, which is 24, right? 4 times 2 times 4 times 2 times negative 3 plus 24. And so this is over 2 times 2, right? 2 times A, 2 times 2. So this is 5 minus 7 over 4. And M2 will be 5 plus 7 over 4. So this is negative 1 half. So this is 3, right? So this function here, this quadratic equation has two different real solutions. So we get y1 is e to negative 1 half x, and y2 is e to 3x. So the general solution is y equal to c1 e to negative 1 half x plus c2 e to 3x. So this is how do we solve this second order linear homogeneous differential equation whose coefficients are all real numbers. So you change from a differential equation to a quadratic equation, and the rules of the roots of the quadratic equation give you the information about the general solution, right? So now let's see one more example. Second example is y double prime minus 10y prime plus 25y equal to 0. We don't have to go through the procedure, so we know that exactly, we know that the auxiliary solution is given by m squared minus 10m plus 25 equal to 0. So this is m minus 5 square equal to 0. So you have a repeated solution, which is 5. In this case, one of the solution is y1 is e to 5x, and the other one, y2, by the reduction of order method, is x times e to 5x. So the general solution is given by y equal to c1 e to 5x plus c2 e to c2 x e to 5x, right? And now let's see the third example. We are given y double prime plus 4y plus 7y equal to 0, right? In this case, the auxiliary solution is given by m squared minus plus 4m plus 7 equal to 0. So b squared minus 4ac, this is what? This is equal to 16 minus 28, which is negative 12. So this is less than 0, right? So we get our two solutions, m1 equal to negative b, right? Negative 4 plus square root of 12i over 2. So if you want to simplify, this is negative 2 plus square root 3i. And m2 is negative 2 minus square root 3i. So we get our real solution here is y1 equal to, this is our alpha, e to negative 2x times cosine of beta square root 3x. And y2 is e to negative 2x sine of square root 3x. Right? And so that's good. I will get our general solution. The general solution is y equal to c1 e to negative 2x cosine of root 3x plus c2 e to negative 2x sine of square root 3x. Okay, now let's try to solve initial uh, initial value problem, right? Number 4 here, we are given uh, we are given 4y double prime plus 4y prime plus 17y equal to 0. We are also given that y of 0 equal to negative 1, y prime of 0 equal to 2. So that's an initial value problem, not a boundary value problem. Boundary value problem, there will be two different points involved, right? Because it's both about 0, so that's the initial value problem. So that's what happens in the initial condition. So how do we do that? We change it to we write down the corresponding auxiliary equation, which is 4m squared plus 4m plus 17 equal to 0, right? In this case, b squared minus 4ac, so which is 4 squared minus 4 times 17. 4 times 68. So this is equal to 16 minus 68. So this is negative 52. 68. B squared minus 4ac. There's another 4 here and time 4 here, right? 4ac. So this is, okay, what's this? If you try to take out the common factor, let me redo all my calculation here, right? Redo my calculation. What's going on? B squared minus 4 times 4 times 17. Common factor is 4 squared, 1 minus 17. So this is negative 4 squared times 4 squared. Right. So this is less than 0. So we have two solutions. M1 equal to negative B, negative 4 plus square root of okay, which is square root of that, which is 4 square, which is 16. 16 I over 2 times A, which is 8. So this is negative 1 half plus 2I. If you get one of them, the other one is a conjugate, which is negative 1 half minus 2I, right? So we get our two solutions. Y1 is e to negative 1 half x cosine of 2x, and y2 here is e to negative 1 half x sine of 2x. Right, general solution is y equal to c1 y1 plus c2 y2. And because y of 0 equal to negative 1, y of 0, so because sine of 0 is what? Sine of 0 is 0, so y of 0 equal to negative 1 implies this term is 0. Y1 of 0 is 1, right? So implies C1 is negative 1. And Y prime of X is, now we need to do some calculations, right? And so which is C due to that, C1 negative 1 half e to negative 1 half x cosine of 2x, and then minus e to negative 2x sine of 2x times 2, right? Cosine prime is negative. And then plus c2 times y2 prime negative 1 half e to negative 1 half x sine of 2x sine of 0, 0, that doesn't matter. Then top plus 2 times e to 1 half x cosine of 2x, right? Chain rule. So if you plug in y prime of 0 uh, equal to what? Equal to 2. And also C1 is C1 is negative 1, right? So this is negative 1. And so you get C2, this part give you negative 1 half, 2 minus 1 half. This part give you 2, okay. So you get C2, do a calculation here. This is TC2 is uh, 3 over 4. So the solution for the initial value problem is given by y equal to 2 times e to 1/2 x cosine of 2x plus 3 over 2. No, that's wrong, right? C1 is -1. So this should be -1. And e to -1/2 x sine of 2x. So for this initial value problem, so that's the solution we have for this equation, for this initial value problem. So all our examples, we have a second order linear homogeneous equation, differential equation whose constant, whose coefficients are constant. So we change our equation to a quadratic equation uh, based on what's the form of the roots. We have a different format, different form of the general solutions, right? Either you have two real different roots, one repeated one, or two conjugate complex roots. We can get a solution for of the initial second order linear homogeneous differential equation.